Okay, so okay. So good morning everyone. So last time na discuss na natin yung basic tawag dito, basic properties of light, yung reflection, refraction, dispersion, total internal reflection, and propagation of light. Okay. So now we will discuss further about reflection, refraction for different types of materials. Right? So meron tayong mga plane surfaces, spherical surfaces, mirrors, and thin lenses. Okay. So for this lecture, we define ang tawag dito, some terminologies. So when we say object for geometric optics, okay, when we say any object, it's anything from which light radiate. Okay, so light could itself be emitted by the object. Okay, so such as yung mga sources of light natin like fire, discharge tubes, and lamps. And light could also be emitted by another source and then reflected from object. Okay, so pwedeng yung light coming from the sun, it reflects on the surface of these apples or the car, tapos yun yung nakikita natin na light. Okay, so yung object, possible siya na maging, for example, yung mga tawag dito, mga apples, ganyan, or anything, pwede pa rin sila maging source ng light kasi nagbabounce yung original source dun sa surface nila. Okay? And there are two types of object. Okay? So, pwede siyang point object, sabihin walang physical extent, walang height. So, for here, for example, yung point P is a point object. It's a source of light or light rays. And wala nga siyang dimensions. So, wala siyang dimensions, wala siyang length, height, radius, etc. Okay. However, for an extended object, these are real objects with length, width, and height. So, may volume, may area, etc. And it's made up of very large number of point objects. So, a collection of point objects is called an extended object. Okay. So, yan yung object natin. Now, on the other side of the material, after ng reflection or refraction happens, meron tayong image. Okay? So, image is a point or set of points from which rays converge towards or appear to diverge from. Okay? For example, here, may object tayo dito sa taas, yung cut, and then nagre-reflect back siya dun sa surface sa bottom. So, may image na form dun sa bottom. Okay? Same with this wolf. Okay, meron siyang reflection towards the surface of the lake. Okay, or the polo. And there are also two types of images. So kung may two types of objects, may extended and point object, meron ding types of images. So a real image is any image that is formed before the surface. Okay? For example, ito yung object, so yung source of light rays, right? Yung light rays na yun, pwede nating i-drawing, magre-reflect through the surface of the mirror. Okay? Kung saan converge or kung saan intersect yung dalawang light rays, dun mafo-form yung image. So, here. Okay? Kapag yung image na yon na-form before the surface, the reflecting or the refracting surface, then the image is considered to be real. Okay? So, these are formed by light rays, and outgoing rays really do pass through an image point. So, ito yung mga incident, right? Incident rays, yung papunta pa lang sa mirror. Outgoing rays, yung palabas na sa mirror. So, pag nag-intersect sila through a point, that image will be real. Virtual image, on the other hand, na-form naman siya on the backside of the surface. So, on the other side. Okay? So, kung yung image na form before the mirror, real siya. Kung yung image na form after the mirror, it's a virtual image. And here you will see that the rays coming from the object does not intersect on that image point. Okay? So outgoing rays do not actually pass through the image point. Okay? So this image is formed by sightlines. So for example, kung may ray ka na nandito, outgoing niya, pag ganun, yung sightline nito is i-extend mo lang up to dun sa location behind the mirror. Same with the other ray. So ito naman, magkakaroon ka ng law of reflection here, law of reflection there. Okay? So ito yung outgoing, ang gagawin mo, extend mo yung tail niya to the other side of the mirror. Kung saan sila mag-intersect, nandun yung image, which will now be virtual. Okay? Kaya siya sightlines kasi ina-extend lang natin yung rays on the other side of the mirror. Hindi talaga nag-i-intersect yung rays dun sa image point. Okay? So now, we define yung object distance and image distance. So object distance, denoted by SO, is the distance between the object and the surface or the interface. For example, here, kung meron tayong plane mirror, ito yung incoming light ray, ito yung outgoing light ray. S0 is defined to be the object distance, the distance from the point object through to the surface or the interface. Okay. So yun yung S0. If the object is on the same side of the incoming light, okay, kung yung object mo nasa incoming plane or incoming ray, then S is positive. Yung S0 natin, ang magiging sign, positive. Kapag yung object nandun sa other side, okay, not in the same side of the outgoing ray, then object is negative. Okay? So, object distance is negative. So, pwede rin maging negative yung object distance. Okay? So, ito yung sign rules for your object distance. Okay? So, ang cue lang dito, hanapin nyo kung nasan yung incoming rays, i-drawing nyo from the object, pati yung outgoing rays. Okay? Tapos, tinan nyo kung nasa same side or opposite side. So, if the object is in the same side of the incoming rays, positive yung sign na gagamitin nyo for the S0. Kapag opposite side, then negative. Okay ba yan? For the image distance, it's about the outgoing side naman. Okay? So, the image distance is the distance between the image and the surface. And yung sign rules is with respect dun sa outgoing rays. Okay? Which makes sense kasi yung image gusto mo ma-form sa outgoing plane. Okay? Yung object, ina-assume natin na nasa incoming plane. So kung object nasa same plane ng incoming rays, positive. Kung ang image na form sa same side naman ng outgoing plane, positive din siya. Otherwise, negative yung magiging sign. Okay? So yun lang yung kailangan yung tandaan dito, yung mga sign rules. And for other properties, so we can define or obtain the lateral magnification. So this is just the ratio between the object and image height. Okay, so meron niyang 3 equalities. So pwede niyong gamitin si M equals YI over YO or negative SI over SO. Okay, so yung M, ito yung magnification. YI and YO are the object heights and image heights. Okay. So ratio lang siya ng image over object height or negative ratio ng image distance and object distance. Okay. So pwede nyong takpan yung first, tapos equate nyo lang yung dalawa, yung second and third. Pwede nyo takpan yung second, equate yung first at third. Pwede na matakpan yung third, tapos equate nyo yung first and second. Depende kung anong given. Okay. So, triple equality ulit yan. Okay. Sign conventions. If M is greater than 0, if M is positive, kapag may magnification na nakuha natin ay positive, then ibig sabihin, yung image na na-form has the same orientation with the object. Okay? So, kung initially upright yung object, yung ma-form na image, upright din. Yun lang sinasabi ng positive M. Kapag negative yung M, sabihin, nag-invert yung image. Okay? Inverted yung image with respect dun sa object orientation. Mamaya, may kita natin yung some examples of this. And dun naman sa magnitude ng M, kung syempre, magnification yan, kung M equals 1, same size lang yung object. Hindi nagbago yung height. Right? Kasi nga ratio siya ng height. So, kung M equals 1, that means equal lang yung magnitude ng height ng image saka magnitude ng height ng object. Kapag less than 1 yung magnification, alam natin, lumiit yung object. So, na-reduce yung image. Right? Kung positive naman yung magnitude, or kung greater than 1 yung magnitude, then na-magnify yung image. Sabihin, lumaki yung image. And mas may kita to kapag nag-ray tracing tayo later. Okay? For the heights naman, kung positive yung mga height na nakuha natin, that means upright yung images. Upright yung image or upright yung object. Negative yung sign convention na ginagamit if inverted yung image or yung object. Okay. And then again, kung SI is positive, sabihin na form siya dun sa outgoing plane, that means real yung image. Okay? Kapag virtual yung image, na form siya on the other side of the outgoing plane, then virtual yung image. For example, ito mga iba't ibang cases, okay? We have here in object, the candle, reflecting on a plane mirror. So plane surface muna tayo. So the object has this distance SO from the plane mirror and a height YO. Okay? And then we draw rays coming from this point dun sa of the extended object. Okay? So a straight line ray will just reflect through the plane mirror. Okay? Using your special case ng law of reflection. This is striking on the normal of the plane mirror. So alam natin may reflection siya just on the opposite direction. Okay? Pero again, pwede nating extend yung ray na yon, yung tail na yon hanggang dito. Okay? Kapag naman yung ray nag strike doon sa mirror at an angle, law of reflection naman yung gagamitin natin. So meron kang law of reflection, and then ito yung outgoing ray, and then we can extend the tail, again, the tail of that outgoing ray back to the backside of the mirror. Okay? So here, meron silang intersection point. Doon naman mafo-form yung image. Okay? Since yung image na form on the other side of outgoing plane, again, ito yung incoming plane, nandito yung incoming rays, ito yung outgoing rays. So nandito rin yung outgoing plane. Since yung image na form on the different side ng outgoing plane, then image is virtual. So, whatever yung SI na makuha natin, that will just be a negative number. Okay? Negative yung sign ng image distance. Okay? So, for a reflection on a plane mirror, image is always virtual. Take note, yung magnitude nila is the same. Okay? Kaya kapag tumitingin tayo sa plane mirror, parang twice yung distance from the image na nakikita natin papunta sa atin. Kasi yung distance natin from the mirror, tas yung distance ng image form from the mirror are the same. So kung makita natin yung image natin sa mirror, parang mas malayo siya. Diba? Which is twice yung distance natin from the mirror. So dito nabubuo yung notion na yun. Okay. For the heights, image is always upright. So kung yung object, if you place it in front of the mirror, same lang din yung height. That's why if tumingin ka sa mirror, hindi nagbabago yung height mo. Okay? So, any object na in front of the mirror, hindi magbabago yung height. Okay? So, always upright with respect to the object. Lagi silang same ng orientation, hindi rin bumabaliktad. Tama? So, try nyo ngayon. Tumingin kayo sa mirror. Meron kayong malapit na mirror, hindi babaliktad yung image nyo. Okay? So, since equal yung magnitudes ng height, yung magnification, which is yi over yo, is just 1. Right? So, laging 1 yung magnification. Sabihin, hindi mamamagnify, hindi mare-reduce. Hindi lalaki, hindi liliit yung image. Okay? And positive meaning upright. So, if m is positive, then upright yung image with respect to the object. Okay? For example, a candle with this height for 4.85 centimeters is situated left of a plane mirror. Where is the image formed and what is the height of this image? So, given is S naught is 39.2 and Y naught 4.85. Now, very important, bago nyo isulat yung given, identify nyo muna yung signs na gagamitin. Okay? So, yung candle is to the left of a plane mirror. Okay? So, nandun siya sa incoming side ng plane mirror. So that, positive yung gagamitin nating S naught. Now, for the height, pwede natin i-assume na upright muna yung object para positive din yung YO natin. Unless stated dun sa problem. Okay? And since this is a plane mirror, we can easily find the image distance and the image height using equations natin for the reflection on the plane mirror. Okay? So image distance is just the negative of the object distance, and the image height is always the same as the object height. So image location will be 39.2 centimeters, okay, to the right of the plane mirror. Okay? So pagdating dito, if we plug in yung 39.2, negative yung makuha natin. Okay? So meaning, sa equations, negative yung ginagamit natin na SI. Okay? But pag isusulat natin, pag i-report natin yung image location, kung negative yung nakuha nating SI, that means siya ay formed on the other side of the outgoing mirror. Okay? So kung ito yung mirror natin, right? Ito yung object, may object tayo dito. Nag-reflect. Okay? Nag-reflect. So yung image na na-form, nandito siya. So ito yung SI, magnitude ng SI, image distance, right? Pero yung sign niya, negative kasi alam natin na nandito yung outgoing ray. Okay. So siya ay on the other side of the outgoing ray. Therefore, negative lang yung ginagamit pag pinasok na natin sa equation. Okay. But if we report, mawawala yung negative. Sasabihin lang natin kung ano yung distance with respect dun sa interface or of the mirror. Okay? Okay ba yan? Okay. So, virtual yung image. For the height, it will just be the same. Okay, so same lang yung image height and object height. Okay. Question? Question ba about the plane mirror? Okay, so kung wala, let's continue. Now, let's deal with spherical surfaces naman. Okay, so kanina plane surfaces. Now, let's deal with spherical surfaces. So kung spherical surface yan, meron niyang center of curvature and radius of curvature. Okay, the center of curvature C is the center of the sphere for which the surface is a part of. Okay, so kung ganito yung spherical surface, right, yung C will be, drawing lang natin yung center. Kung imagine natin na buong circle yung surface na yon, yung center nun, that will be the center of curvature. Okay? And yung radius of curvature will be the distance from the center of curvature to the interface or to the surface. Okay. So, if the center of curvature is on the same side as outgoing light, R would be positive. Okay. But if the center of curvature is not on the same side as outgoing light, R is negative. Okay. So, ganito lang. Kung reflection, right? Ang reflection, yung incoming at outgoing light at incoming plane at outgoing plane should always be the same. Kasi nga, reflection yung kinukuha natin. Okay? If the light ray strikes dun sa curve na parang deep, ito, so that will be a convex, right? Parang convex, R is positive. Pag yung light ray tumama sa surface na kung saan parang mountain, parang bundok, right? Then R is negative. Okay. And this is just true for reflection. Kasi nga, yung incoming sa outgoing plane are the same. Okay? So, pwede nyo itong imaginein. Try nyo kumuha ng kutsara. Okay? So, tingnan nyo yung image na ma-form. Tingnan nyo yung image na ma-form doon sa one side ng kutsara, saka doon sa other side. Right? So, ito yung one side ng kutsara, spoon, tapos ito yung other side ng kutsara. So, pwede nyo ngayong paglaruan, ano yung ma-form na image, kailan magiging inverted, kailan magiging hindi. Okay? Kasi reflection din naman yan. Okay? Now, special case, if the reflecting or refracting surface is a planar, yung R, infinite. So, yun lang yan. Okay? Positive, yung R, yung radius, kapag the center is on the same side of the outgoing, negative kapag on the opposite side of the outgoing, infinite naman yung R kung plane, reflecting, or refracting surface. Okay? So, sign rules for reflecting. So, here, the center of curvature, C, is on the same side of the outgoing rays. So, R must be positive. That means, concave yung mirror. Okay? Or converging yung mirror. Okay? Ito pala yung concave. Okay. Now, convex naman kapag tumama yung rays dun sa mountain side or sa hillside. Okay? Kung parang bundok yung pagtama nung rays, convex naman yung mirror or diverging. So, negative yung R. Okay? Pag tumama siya sa parang pa-cave, concave, R greater than 0. Pag tumama siya sa parang bundok or hill, diverging or convex yung mirror. Okay? So, yun yung pwede nating tandaan. Okay? Now, this radius of curvature is very important kasi it relates with the focal point and focal length. Okay? So, given your radius of curvature R, the focal length is just R over 2. Okay? So, ano ba tong F na to? So, here, for example, meron tayong meron tayong source of rays very far. Okay? Very far from the mirror. So, that S naught, yung object distance is infinite. So, very far from the mirror. Okay? If that is the case, then the light rays coming from that object situated at infinity from the mirror, magiging parallel rays na lang lahat yon. Okay? Once these parallel rays strike the surface of the mirror, magkakaroon ng law of reflection for each of these points. So mag-a-apply tayo ng law of reflection, etc. And they will always converge on the focal point F, which is situated half the radius of the curvature. Okay. So yun lang yung sinasabi ng focal point. Okay. And focal length. Kung ano man yung F na to, that will just be the image distance r over 2. Okay. For which, kapag yung object is situated very far from the surface. Okay. So mukha siyang hindi mangyayari, pero lahat ng nandito sa points on the curvature ng surface, lahat yan nag-o-obey ng law of reflection. Okay. So sign rules. So this will just follow from the radius of curvature. Right? So kung R is positive, then F is also positive. Right? So kung concave, yung mirror, converging like this, nagko-converge yung light rays, then positive yung F and R. Kapag diverging naman yung case kanina, eto, nagda-diverge yung mga rays from the C and from the F, then negative naman yung sign for both F and R. So same lang yung sign rules for F and R. So some cases, kung point object, the image formed on a concave mirror, something like this. So meron kang object situated at an S0 to the left of the center of curvature. Okay. So yan yung light ray na galing sa object. It will hit through the normal of the concave mirror. So using law of reflection, ito yung ma-form na image which will now be situated SI. Okay. And we get an object-image relationship given by this equation. Okay. So actually, itong object-image relationship is true for any surface. Okay. Kahit yung pagdating sa thin lens, ito pa rin yung gagamitin natin. 1 over SO plus 1 over SI equals 1 over F or 2 over R. Okay. So kung hindi given yung focal length, pwede nyo gamitin yung 2 over R. Kung hindi given yung radius of curvature, yung 1 over F naman yung gagamitin nyo. Okay. So same lang yon. Again, this is a triple equality. Okay. So pwede nyo gamitin any two of these pairs. Any pair from this triple equality. Okay. Now, kung plane yung surface, ano yung sabi natin kanina? Kung plane yung surface, the radius of curvature R is infinite. So this, a constant over some infinite, approaches 0, right? For when the limit is taken. Okay. So this is infinite. So if this R is very large, then this whole fraction will become very small. So kung very small, it approaches 0. Therefore, 1 over F approaches 0. And so, makita natin, yung 1 over SO and 1 over SI equals 0. So, if we rearrange, makuha pa rin natin yung nakuha natin kanina, which is S0 is equal to negative SI for the plane mirror or any plane surface. Okay. So, wala tayong na-violate na any formulas from before. Okay. Now, for an extended object, kung hindi na siya point object, extended object, situated S0 from the concave mirror, we have this rays, and we will see that this rays will converge on the image, right? So image here will now be a real image, and we still use the same formula for the object-image relationship and the magnification as well. So actually, itong dalawang to, true to for any geometric optics. Okay. So lagi yung gagamitin ito. Ang kailangan nyo lang matandaan or maintindihan is ano yung magiging sign ng SO, SI, F, R, YI, YO, and M. Right? So, yun lang yung kailangan yung isa puso with this. Okay? Okay? Questions so far? Questions? Okay? So, kung walang questions, let's continue with ray tracing. So, sabi natin, yung ray tracing makakatulong to see where the image is formed. And there are 4 useful rays, or actually, you just need only 2 but there you can draw up to 4 rays para ma-sure kayo, right? First is the ray parallel to the optical axis. So this line through the center of curvature and through the focal point, yan yung optical axis. Okay? Usually, nag-a-align tayo with respect to this optical axis. Okay? So any ray parallel to the optical axis, okay, let's say we draw that from the tip of the extended object. So ito yung ray 1, right? Mag-hit siya dun sa concave mirror. Pagdating sa concave mirror, we apply law of reflection. Yung outgoing ray, yung reflected ray, will pass through the focal point. Always that. It's always the case. Okay? So any ray that is parallel to the optical axis, once it hits the surface, spherical surface, okay, after ng law of reflection, yung dadaanan niya yung focal point. Okay? Now we have another ray through the focal point naman. So what if the ray na drawing natin passes through the focal point and then strikes the concave mirror? Okay? Baliktad naman. So kung kanina, any parallel ray will reflect to the focal point. Ngayon, any ray through the focal point will reflect parallel to optical axis. Okay? And then, meron pa tayong third ray. So, any ray passing through the center of curvature will just be reflected back to its original path. So, magba-bounce back lang siya. Okay? And any ray through the vertex, so ito, mas obvious na law of reflection siya, so it will be reflected symmetrically with respect to the optical axis. Okay. But in this case, lahat to nagpo-follow ng law of reflection. Okay? Dun sa ray through the center of curvature, tong ray 3, right? Kaya siya nag-bounce back kasi if the ray passes through the center, alam natin mag-strike yung ray with respect, normal with respect to the concave mirror. Right? So this is just parang striking through the normal axis. Kaya magba-bounce back lang siya. Okay? And here we will see where the image is formed. So kung saan sila nag-intersect after ng outgoing, kung saan nag-intersect yung mga outgoing rays, doon ma-form yung image. Okay? So, to find the image using ray tracing, we can just use any two. Right? Hindi naman ang kailangan natin lahat ng 4. Okay? So, any two will do. You can use the ray parallel to optical axis, the focal ray, the central ray, or the vertex ray. Okay. So, any of those, just choose at least 2, you will now find the image using ray tracing. For example, a mosquito landed 20 centimeters in front of a concave mirror with a radius of curvature of 20 centimeters. How far from the mirror will the mosquito's image be formed? Okay. So, concave. So, ano yung tsura niya? Para siyang pa-cave. Okay? And since concave, yung R na gagamitin natin will be greater than 0 or positive. So, dito na important yung pag-apply ng sign conventions. Okay? S naught is 20 centimeters, positive. R will be positive 20 centimeters. Nahanap ay image distance. Okay? Since R yung given, we can use this equation. Okay? Kung focal length yung given, 1 over F lang yung magiging right-hand side. Okay? So, yun. Any of those three, triple equality can be used. Okay? So, SI yung hinahanap, alam natin yung SO, alam natin yung R, plug in our values, we will get 20 centimeters for the image distance. Okay? So, take note, SO is 20 centimeters. SI is 20 centimeters as well. In this case. Okay. And positive yung nakuha nating SI. So, kung positive yung image distance, that means the image is formed in front or to the left of the mirror. Right? and same position as the object. Kasi yung outgoing ray ng mirror is in the same plane of the incoming ray. So, ito yung diagram. So, this is the object. Okay, situated 20 centimeters. So, yung R, yung radius is also yung 20. So, nandito yung object sa may center of curvature actually. Okay. Magre-reflect siya. Ito yung focal parallel ray. Ito yung focal ray. So, ma-form yung image dito rin. Okay. On the same position as the object. Okay. So, pwede kayo mag-ray tracing para ma-check. So, sanity check or ma-verify yung nakuha yung image distance. And even the height or the image height. Right? So, makikita natin dito, yung formed image is negative dapat yung height. Kasi inverted naman yung image. Okay? Okay, now for a point object. Okay? Ito naman yung image formation by convex mirror. So, kanina concave mirrors. Okay? Let's now consider convex mirrors. For point object, situated distance SO. So, let's draw one ray. So, by law of reflection, ito yung maging outgoing ray. And if we extend the tail of this ray, yung image will be formed here. Okay? So, ganun din. If we draw another ray, law of reflection ka dito sa surface, kung saan sila mag-intersect with the other ray, doon ma-form yung image. Okay? So, the image is formed on the opposite side of the outgoing ray. Okay? For the object-image relationship, we still use the same. For the magnification, we still use the same. Okay? The object, we draw two rays, extend natin sila. Kung saan mag-intersect, nandun yung image. We have this and the magnification. So, same lang lagi equations. Okay? Ang mag-iiba lang is yung signs. So, ano yung tsura ng ray tracing for convex mirrors? Okay. So, again, we have these four rays, a parallel ray to optical axis, the reflected, the ray through the focal point. Okay. So, if we try to extend this, mag-extend to through the focal point. Okay. Tapos, magre-reflect siya dito, reflection. Okay. Then, we have the ray through the center of curvature and the ray through the vertex. So, if you notice, kahit convex yung mirror, hindi na siya concave, same pa rin yung mangyayari dun sa mga rays na ginagamit natin sa ray tracing. So, any parallel ray will be reflected through the focal point. Any ray through the focal point will be reflected parallel naman. Any ray through the center is reflected back to its original path. And any vertex ray will be reflected symmetrically via law of reflection. Okay. So, the image is formed kung saan sila nag-intersect, kung saan nag-intersect yung sight lines. Okay. Kapag in-extend natin. But we can always use any two. Okay. So, kailangan natin ng two rays for the ray tracing para malaman kung nasan yung image. Okay. So, let's go back to our previous example. What if now the mosquito is in front of a convex mirror? Okay. This time, since convex mirror, negative naman yung sign na gagamitin natin. So, convex, mali to. So, mirror is convex. R should be less than 0. Okay? So, dapat to ay convex. Okay? So, this time, negative yung R. We still use the same equation, right? So, yun ang gumbagang equation natin. And this time, yung SI na makuha natin is negative. So, what does this mean? Kung negative yung image distance, that means image is virtual. Okay? So, that will be behind the mirror. So, paano natin magre-ray trace? So these are the two rays. Meron tayong parallel ray and then ray through the center of curvature. Dalawa lang kailangan natin. Alam na natin kung saan sila mag-intersect. Okay? And you will see here, kanina, with the concave mirror, dito na form yung image, which is real image. Ngayon, yung image na form behind the mirror. Okay? So, virtual na yung image. Okay. So, yung distance na to, ito yung 6.67. Negative lang yung sign kasi it's behind the mirror. Okay? Negative din yung sign ng R. So, mali to. Dapat negative to. Okay? Kasi yung center of curvature, behind the mirror din. Okay? Question so far? Okay? Naiintindihan naman. Clear naman. Clear naman yung sign conventions. Okay. So, thank you. So, yun na yung kailangan yung tandaan, yung sign conventions. Yung equations, parehas lang yung gagamitin niya. Okay. Now, let's go to refraction naman. So, kanina reflection. So, kung reflection, same yung incoming plane sa outgoing plane. Right? Kung refraction, iba na yung incoming plane sa outgoing plane. Kasi ina-expect natin, magpapass through yung ray through the surface. So, for a convex refracting interface, so, ito na yung incoming ray, ang outgoing ray is nandun na sa other side. Okay. So, for a convex, yung center of curvature C, same na siya ng side ng outgoing ray. So, that means the radius of curvature is positive for a convex refracting interface. Okay? For a concave, negative naman siya. So, dito lang siya magpapalit ng sign ng radius. Kung reflecting, ang convex, R is less than 0. Kung refracting, convex, R is greater than 0. Okay. Same with concave. For a reflecting concave, R is positive. For a refracting concave, R is negative. And the focal point or focal length F will be the same signs for R kasi nga F equals R over 2. Okay? So, magpapalitan ng konti sa refraction. Okay? So, let's see some cases. Kung point object, ito yung SO. Okay? So, there's these two rays, one through the vertex and one through one point on the surface, right? So, dito, refract. So, may Snell's law na tayo, hindi na yung law of reflection. Snell's law na yung gagamitin kasi refraction na tayo. Kung saan sila magko-converge, nandun yung image. Okay? So, ito, this time, convex refracting surface. Right? But the image is formed on the other side. Now, since Snell's law yung gagamitin natin, magpapalit lang yung object-image relationship natin. So, magiging ganito lang siya. So, actually, galing lang siya sa Snell's law. Okay? So, NA is the refractive index of incoming side. NB is the refractive index of outgoing side. Okay? So, actually, ito, galing lang to sa Snell's law dito. Sa points na to. Okay. So, ito lang yung medyo may iba kasi may NA, NB na yan. So, dependent na siya sa index of refraction. Okay. But still, in-expect natin na yung object is nasa same side nung incoming rays. Tapos yung image naman, in-expect natin na nasa same side ng outgoing plane or outgoing rays. If that happens, then R is positive. If may isa doon na hindi nangyari, R will be negative. Okay? Now, for an extended object, so kung di na point object, we can use ray tracing. Let's draw two lines, one through the center and one through the vertex. So again, this is refraction. Okay? So through the center, okay? So through the center of curvature, kung reflection, magba-bounce back. Right? Kung refraction, magpa-pass through, dire-diretso lang. Kaya dadaan siya dito sa C. Okay? Dun naman sa vertex, kung reflection, Snell's law, law of reflection, magre-reflect symmetrically. Kung refraction, it will be bend away from the normal. So ito yung normal natin. So it will bend away from the normal and therefore, dito siya ngayon dadaan. Kung saan sila mag-intersect, nandun yung image form. Okay? So, this time, again, same lang yung object-image relationship dun sa point object. So, meron ka lang NA, NB sa taas, imbis ng puro 1. And the magnification will now be like this. Okay? Yung YI over YO, same lang. Yung negative SI over SO, same lang, except na meron kang i-multiply na ratio nung indices of refraction. NA over NB. Okay? So take note, yung SO, yung object distance, is situated on the first medium NA, and yung image distance is situated on the second medium NB. Okay. So yun lang yung kailangan nyo matandaan. So since bibigay naman namin yung equations, alamin nyo lang ano yung NA, ano yung NB, ano yung SI, SO. So SO usually nasa NA, NB usually nasa SI. Okay? For example, a fish in a spherical bowl of water is in a spherical bowl of water. The radius of the bowl is 15 cm, and the fish looks through the bowl and sees a cat sitting on the table with its nose 10 centimeters from the bowl. Find the image distance and the magnification of the cat's nose. Okay? So ngayon, we need some leading comprehension. Saan yung object? Saan yung image? Okay? So first, sino yung object natin? Si cat's nose. Right? So ito yung object natin. Okay? So dito ngayon manggagaling yung rays dun sa object. Okay? So ito yung incoming side, and then since magre-refract through the surface of the bowl, andito yung outgoing side. Okay? So let's do that. So the image distance of cat's nose, siya yung object. Okay? We will use this equation. So now, since yung object nasa same side ng incoming rays, then positive yung SO. Okay? Now, the center of curvature nung spherical surface is nandito. Okay? Since nandito yung incoming, ito yung incoming, okay, from the nose, right? Magre-refract through the center. So yung outgoing side is in the same, yung outgoing rays is in the same side ng center of curvature. Therefore, positive yung sign ng R natin. Okay? So take note, here we have now a convex refracting surface. Okay? So with respect sa cat, convex yung surface. Kaya positive yung R. Okay? If in the case na yung object ay yung fish, okay? In the case na yung object ay fish, ang may kita ng fish ay concave naman. So take note of that. Okay? Kapag ang object, yung cat, convex yung may kita niya. So R is positive. Kasi dito manggagaling yung rays. Kapag yung object ay yung fish, concave naman yung may kita niya. Right? Itong concave na to. Therefore, R will now be negative on that case. Okay? So, medyo may counting, reading, comprehension, alamin nyo muna ano yung object, saan yung incoming side, saan siya magre-reflect or magre-refract to get the outgoing side. Okay? Malinaw? Malinaw ba yan? Okay? So, yun lang yung medyo tricky. So, kailangan nyo lang alamin yung kailangan nyo lang ng counting, reading, comprehension with the problem. So, basahin nyo maigi yung problem. Okay? And then, since refraction, di naman reflection to. So since refraction, we'll use this, isolate yung SI, hinahanap natin yung image distance, and we apply or plug in our given. NB, ano yung NB? That is the water, kasi na siya outgoing side yung water. NA, yun yung air, dahil yun yung incoming side. Okay. Kaya NA is 1 for the air, NB is water for the outgoing side. Okay. Plugging in our values, and we get an SI to be negative. What does this mean? Sabi natin, ito yung incoming, ina-expect natin magre-refract, dapat nandito yung image. Since negative, imbis na dito na-form yung image dun sa other side of the outgoing. Okay. So actually, dito pala. Yeah. So negative image, meaning virtual yung image. Okay? Kung positive, dito ma-form yung image sa same side ng outgoing, right? So, real yung image. But since we get a negative SI, yung image na na-form ay virtual, so nasa same side siya ng incoming. Okay? Outside the bowl. Okay? For the magnification, we just use yung magnification equation and we get this. Okay? Negative 1.28. So, since greater than 1, yung magnitude, sabihin, lumaki siya. Right? Lumaki yung image. However, inverted kasi negative yung magnification. So, actually, yung image na form is somewhere here. So, yung image nung cat's nose will be somewhere here. Kasi nga inverted siya. Okay. Tapos lumaki pa. Okay. Question? Okay. So, wala namang question. And again, for a special case, yung plane refracting surface, so kung planar, yung radius of curvature will always be infinite. So using our Snell's law, kung 2 over R, yung right-hand side kanina, actually pala, NB minus NA over R, but R is infinite, the right-hand side will always approach 0. Okay? So for a plane refracting surface, we always have these two equations. Okay? So this time, hindi na S naught equals negative SI. That's only true for reflecting plane surface. Kung refracting, magmamatter na yung indices of refraction. And the magnification will always be +1. So true to for any plane surface. Reflecting or refracting man, the M, the magnification is always +1. Okay? So, sana na-try nyo to yung sa straw in the water. So, laging same yung magnification, right? Hindi magbabago yung size or height o pati yung horizontal dimension ng straw. For example, a speck of dirt is embedded 3.5 cm below the surface of a sheet of ice with this index of refraction. What is the apparent depth when viewed at normal coincidence? Okay. So, meron kang speck of dirt below the sheet of ice. So, ang object natin nasa below the sheet of ice. Okay. So, yung NA will be yung sheet of ice. Kasi nandun yung incoming side. Okay? NB, so magre-refract yung light rays from the dirt through our eyes. E tayo, na observer, nasa above the surface. Okay? So kung may sheet of ice ka, nandito yung dirt, so siya yung object, magre-refract siya ngayon. Okay? Nahanap ano yung apparent depth of the dirt. Okay? So NA is yung ice, NB will be yung air. Right? Ito yung NA, yung ice, NB, air. So, since we viewed at normal coincidence, that means parang plane yung surface natin, and we use these equations. So 0, yung right-hand side. We find SI, and we will get negative 2.67 centimeters. Okay. Negative, that means, kung ito yung incoming side, kung yan yung incoming side, ina-expect natin magre-refract yung ray, so dapat dito ma-form yung image, yung expectation natin. But since negative, hindi dyan na-form yung image. Saan siya na-form? On the other side. So dito na-form yung image. Okay. So yun lang yun. So negative, which means virtual yung image. Okay. And it appears shallower than it actually is. Okay. Actually, same case to dun sa fish, dun sa lake, nung gusto mong i-spear na fish, yung example natin before. So, anything anything na kung ang object is nasa medium higher with a higher refractive index dun sa refracting side, it will appear shallower as we observe from the outgoing side. Okay? So, same case dun sa fish na gusto nating i-spear dun sa dati nating example. Okay? Question? So far? So, yun yung reflection and refraction through any surface, planar or spherical surface. Okay. So, yung spherical, pwede maging convex, pwede rin maging concave. Okay. And finally, let's go to lenses. So, ang lenses naman, di naman siya naiiba masyado. So, lenses are just any system with two refracting surfaces. So, nag-combine na tayo ng dalawang refracting surface. Okay. So, I think nakagamit na kayo ng magnifying lens. Nakapag-play around na kayo ng magnifying lens. So, it's composed of two refracting surfaces. Okay. Although, yung magnifying lens, considered siya as thick lens kasi nagmamatter yung thickness niya. Okay. In our case, for this for 72, we just deal with thin lenses. So, meaning, meron ka pa rin two spherical refracting surfaces that are very close together. And so, pwede nating i-neglect yung thickness. Okay. So, i-assume natin na negligible yung thickness. Kaya nga thin. There could be two types of thin lenses. Okay. So, meron pa rin tayo ng converging and diverging. So, paano ba natin malalaman to? Okay. Converging lens, they are thickest at the center. So, some examples are converging meniscus, a plano convex, and double convex. So, if you see, these are composed of two refracting surfaces, right? This is the first refracting surface. This is the second. Ito naman, plane yung first refracting, second ay ganito. Ito, parehas na curve yung refracting surface. Okay? And, thickest sila dun sa center. Okay? Dito yung pinaka-thick na part ng lenses. Although, we still consider them as thin lenses. Okay? Now, for the diverging lens, they are now thickest at the edge. Okay? As compared sa converging lens. So, meron tayong diverging meniscus, plano concave, and double concave. Okay. So, makikita natin, mas thick sila dito sa edges as compared sa center. Okay? And some notes, we follow the assumptions here that the index of refraction for the surrounding, yung nasa labas, should be less than the lens index of refraction. Okay? For them to be considered thin lenses. Okay? So, for the equation, same lang yung gagamitin natin, actually. Hindi magbabago with dun sa reflecting surfaces, right? So, 1 over S naught is plus 1 over SI is equals 1 over F. For the magnification, same lang. Okay. Pag refraction lang, okay, pag may refracting surface, nagkakaroon ka lang ng NA over NB, etc. So, doon lang magpapalit. Okay? So, same yung equations, same din yung sign conventions. Okay, so wala namang magbabago. So if M is positive, that means same orientation with the object. If M is negative, then inverted with respect to the object. For the magnitude ng magnification M, kung M equals 1, same size. M less than 1, lumiit, reduced. M greater than 1 is magnified. Okay. Same for the height. So kung yi is positive, image height is positive, then upright siya with respect dun sa object. Kung negative yung yi na makuha natin, inverted, etc. And for the real and virtual image, ganun din. So if SI is positive, real image. If SI is negative, virtual image. So same lang yung sign conventions with before. Okay. Now let's look on how to construct these converging lenses. Okay. Converging lenses, actually lenses, any lens has two focal points. Okay. For the case of converging lens, positive yung focal length. Okay? F is greater than 0. Okay? So, for example, here, ito yung lens natin. Right? Tapos, ito yung optical axis. Okay? Let's say this is your F1, the first focal length, and F2, the second focal length. So, yung focal length na to, this is with respect dun sa first refracting surface. Dito. Tapos yung F2 is with respect dun sa second refracting surface. Okay, so dito naman. Actually, baliktad pala. So yung F1, ito yung F1. Yung F2 is ito naman. Yan. Okay. Now, for the first focal point, so if we draw our parallel rays, right? If we apply ray tracing, so from the first focal point, the rays can be traced back as the converging point of outcoming parallel rays. Okay. And the second focal point is the converging point of incoming parallel rays. Okay. So here, in this case, yung source ng parallel rays is kung nasan si F1, right? Siya yung source of incoming parallel rays. Magko-converge ngayon dun sa F2. Okay? Lahat nitong parallel rays na to. So, ganun lang yung ray tracing nito. Okay? Yung F1, yung source of these parallel rays, okay? Magko-converge sila on the F2 side naman. Kaya siya converging lens. Now, paano na-form yung image? Okay? Let's say we have an extended object. This is your parallel ray. Okay? It will pass through this lens. Okay? Next, we have a central ray or center ray through the center of the lens. So, magpapass through lang siya. And the focal ray, which passes through the first focal point, F1. Okay? So, any parallel ray will refract through the F2, the second focal point. Any ray through the center will just pass through, will be transmitted. Any ray passing through the first focal point will be refracted parallel to the optical axis. Okay? And then, kung saan sila mag-intersect, nandun yung image. Okay? So, dito naman, tatlo lang yung rays natin for the ray tracing. But you can choose, again, any two. Okay? If yung object situated farther from the focal point or the focal length, so ito yung first ray, the parallel ray, this is the central ray, this is your focal ray. So ano yung ma-form na image? That will be a real image, reduced and inverted. Bakit siya real? Kasi na-expect natin na ito yung incoming side, ito yung outgoing side. Since yung image na form dun sa outgoing side, then real yung image. Okay? Reduced kasi mas lumiit. Right? Inverted, so medyo obvious naman na na-invert yung height ng image. Okay? So, ma-form siya on the other side ng optical axis. Okay? So, this is always the case. When S0 is greater than F, ito lagi yung image natin na ma-form. Real, reduced, inverted. If the object is situated exactly at the focal length, we draw the rays. Nakita natin, walang intersection sa outgoing side. Meaning, no image form. Okay? So, no image form. Kapag yung object is less than the focal length, situated less than the focal length, ma-form yung image virtually naman. Kasi, again, ito yung na-expect nating object outgoing side, pero yung image mag-intersect, yung rays mag-intersect dito, which is on the incoming side. So, image will be virtual, magnified, and upright. Okay? So, always the case yan for the converging lens, where S0 is less than F. So, magpapalit lang. If S0 is greater than F, real, reduced, inverted. If S0 is less than F, virtual, magnified, upright. Okay? For the case of diverging lens, so in this case, negative naman yung focal length. So again, two focal points pa rin siya. Negative naman yung focal length, and yung image na ma-form is on the opposite, is on the same side ng incoming rays. Okay? So the first focal point can be traced back as the diverging point of outcoming parallel rays. Right? So ito yung incoming, magre-refract, ito yung outgoing. Kung saan mag-intersect yung mga outgoing, dun sila, nandun yung first focal point. Okay. Second focal point naman, kung nasaan yung, ay baliktad. So ito yung F1. Okay. Right? So F2 naman, kung nasaan sila nagda-diverge from. Okay. So here, important lang, kung diverging lens, negative yung focal length, negative din yung R. Okay. So how do we locate the image form? So meron pa rin tayong three principal rays, yung parallel ray, yung central ray, and yung focal ray. Kung saan ngayon nag-intersect yung sight lines or kung yung diverging lines, nandun yung image form. Okay? Again, there can be three cases. If the object is very far away from the focal point, this is your parallel ray, central ray, focal ray, then the image form is always, ano to? Reduced, virtual, and upright. Okay. Now, if the object is on equal to the focal length, okay, if the object is equal to the focal length, so nasa focal point siya, ito naman yung image form. Virtual, reduced, and upright then. Okay. And if the object is less than, if the SO is less than F, so mali ito. So dapat less than na to. Okay. So, yung image naman na form after ng parallel ray tracing is this. So, virtual reduced upright. So, makita natin, wherever the object is located, kung diverging lens, laging virtual, reduced, and upright yung image. Okay? As opposed to sa converging lens na pwede mag-iba. Depende kung nasan yung object. Okay? For example, a lens forms an image of an object. The object has the image of an object is situated 20 centimeters from the lens. Okay? And the object is situated 16 centimeters from the lens. Okay? And nasa same side yung object at image natin. So what is the focal length and what is the height of the image? Okay. So ano to? The image of an object 16 centimeter from the lens forms at 12 centimeter from the lens. So yung image distance is yung 12, yung object distance is yung 16. Okay? Yung object distance should be positive, but the image distance is negative kasi nasa same side siya ng object or same side siya ng outgoing plane. Okay? So this time, negative yung SI, positive yung SO. Okay? Given din yung YO, yung image height. So, we apply yung thin lens equation natin. We find for the focal length and we get a negative, which means kung negative yung focal length, that will be a diverging lens. Okay? For the height, ano makukuha natin? Gamitin natin yung magnification formula. Okay? So again, this is a triple equality. So hindi natin kailangan i-solve yung M kasi alam naman natin yung YO, SI, and SO. So ito yung gagamitin nating part. Okay? So ito lang yung kailangan natin gamitin here. We find the image height, YI, and we get a positive. So this means yung image natin will be erect or upright with respect sa object. Okay? Tapos, lumiit din. So, ano yung YO? 0.85. Yung YI, 0.6, which means na-reduce din yung image. Okay? So, ayun. So, madali lang i-apply yung thin lens equation. It's just medyo reading comprehension lang with respect sa problem. Okay. Okay. So, anong diagram nito? So, this is your object. If we draw our rays, alam na nating diverging yung lens. So, ito yung parallel ray, central ray, and then focal ray. Andito yung object. So, it's a virtual object. Negative yung SI. Upright, kasi positive naman yung YI. But reduced, kasi mas maliit yung image kaysa sa object. Okay? Question? Question so far? Okay. I think yung iba sa inyo is nagawa na to sa lab, right? So, medyo review na lang din to for some. Okay. Now, you may ask, what if dalawa yung lenses? Or tatlo or many lenses? Okay. So, kapag ganoon, isa-isahin lang natin. So, for example, we have these two converging lenses with focal lengths 8 and 6. And may distance sila 36 centimeters apart. And an object is placed to the left of lens A. Find the position, size, and orientation produced by this lens combination. Okay. So sabi, converging lens. So yung focal length na 8 at 6 should be positive. So yun yung unang yung isusulat. So FA is positive 8, FB is positive 6. And then, object is to the left of lens A, so that will be a positive S0 with A and a positive image height of 8 centimeters. Okay. And we take note of the distance between lenses A and B. Okay. So to locate the location of final image, tingnan muna natin with respect sa lens A. Okay? So with respect sa lens A, we apply our thin lens equation. Alam natin yung FA, alam natin yung S naught A, and we calculate for the image distance formed by lens A. So that will be 24 centimeters positive. So kung positive yung image form, that will be on the outgoing side of the lens A. So kung ito yung lens A natin, right? FA1, FA is 8 centimeters, S naught is 12 centimeters. If we draw our rays, the image is formed on the outgoing side. So positive 24. Okay? Now, with respect to lens B, ito na yung magiging object to the lens B. Kung ano yung image ng lens A, yun yung magiging object sa lens B. Therefore, yung distance, yung SO for the lens B will be this. So that will be 36 minus 24, and this is just 12 centimeters. Okay? So that will now be your object for the lens B. Okay? So for the lens B, ito na siya. So 12 centimeters na yung SO, we apply the thin lens equation, and we get this image distance with respect to B. So kung positive yan, yung image distance natin, so nasa outgoing side siya ng lens B, that means to the right of lens B. So how do we draw it? Okay. So first height muna. So ano naman yung height ng first image? So gamitin natin yung magnification equation. Alam natin yung YO. So YI, A will be this one. This value. So pwede natin i-plug in yung YO, yung SIA, saka SOA. Okay? That will be the height after passing through lens A. Tapos, kung ano yung height ng image na yan, yan yung magiging height ng object for the lens B. And so, YOB is equal to this YIA. Applying again the magnification equation, we get this. Okay? So, ito na yung from the magnification equation, but we know that YOB is equal to this. So, i-plug in natin yun dito, and we get a positive image height. So, the final image is upright with respect sa object. Okay? So, ito na yung final image. So, if we draw, ito kanina yung image from lens A. Drawing natin yung principal rays, we get this image. Right? And makita natin, yung image is formed on the right side of lens B, which means real yung image, and upright with respect sa object. Okay? So after passing through lens A, inverted siya with respect sa object, but after passing through both lenses, upright siya with respect sa object. And magnified. Okay? Question? So ganun lang, kung mayroon kayong system of lenses, isa-isahin nyo lang. Okay. And finally, we have our Lensmaker equation. So this Lensmaker equation, ginagamit to make a lens. Okay? Pero actually, si Lensmaker, tao siya. So, surname talaga yung Lensmaker. Nagkataon lang na yung equation niya is used to make lenses. Okay? And in general, ito yung equation niya. So 1 over f, n minus 1, 1 over r1 minus 1 over r2. Where n is the index of refraction of the thin lens, r1 is the radius of curvature of the first surface, and r2 is of the second surface. Okay? And for the signs, kung nasaan, again, same dun sa ginagamit natin before, location ng r, if the location of R1 or R2 is on the same side as outgoing, positive, is on the opposite side, negative. Okay? And the sign of F determines whether the lens is converging or diverging. So, kung yung makuha nating sign dito ng F, siya yung magsasabi kung converging or diverging yung lens. Okay? For example, so bigay lang ako ng 2 examples, si A saka si B. Okay? Actually, hindi kaya naman to. So, for each of these thin lens in the figure, calculate the location of the image of an object 18 centimeter to the left of the lens. Okay? So, the lenses have this index of refraction, 1.5, and the radius of curvature shown are magnitudes only. Okay? So, for this, alam natin yung N, alam natin yung SO, which is always 18 centimeters. Okay? And, hinahanap yung SI. Okay? So, for the F, gagamitin natin yung Lensmaker equation. But for the SI, we use yung thin lens equation. Okay? So, yung 1 over F is thus this. So, for all of this, ito yung gagamitin natin. Okay? Ang magmamatter lang is yung signs ng R1 and R2. So, if we plug in our Lensmaker equation to our thin lens equation, we get this. Okay? Now, for A, for lens A, R equals 10 and R equals 15. Okay? If the object is formed here, ito yung incoming, right? So, tatama siya on a convex. So, if convex, ang magiging sign niya will be, ang sign ng R1 will be positive. Okay? Now, magre-refract siya sa loob, tapos tatama naman sa R2, which is yung 15 centimeters. Since concave naman to, yung R2 will be negative. Okay? So, ganun lang. Applyan nyo lang for each surface. Now, we plug in our values. Alam natin yung N, alam natin yung SO, and we get this image distance. Okay? For lens B, R1, convex, so positive 10. But now, R2 is flat, so infinite naman siya. So, yung 1 over R2 is 1 over infinity, so that it will approach 0. So, mawawala na yon, meron ka lang 1 over R1, and we get this value. So, ganun lang. So, kailangan nyo lang malaman ano yung R1 and R2, yung signs ng R1 and R2. For lens C, concave. So, concave siya sa start, that will be negative. Then, yung R2 is convex with respect sa object, so positive. Okay? And for lens D, concave, so negative, tapos concave ulit, so negative din yung R2. And we get this. Okay? Okay ba yan? So, that is how we apply Lensmaker equation to use to create any lens, to make any lens. Okay. So, actually, yan din yung ginagamit to make your eyeglasses or sunglasses. Okay. Kung ano yung grade, pag sinabi yung 500 yung grado, that means 5.00 yung focal length. Okay. Sabi 125 yung grado ko, 1.25 yung focal length. Okay. Yung converging or diverging will depend kung nearsighted or farsighted ka. Okay? Kung paano mo ma-correct yung mata natin. Okay? So, sa tingin nyo, hindi ginagamit to, actually, ginagamit yan sa sa optometry and ophthalmology. Okay? Questions so far? So that is just for today. So we discussed reflection and refraction through different types of surfaces. Planar, spherical, and thin lenses. Okay? So for tomorrow, mag-upload na lang ako ng another DQ. And then next week, Tuesday, final discussion na natin. Okay, last discussion na. Okay ba yan? Okay. Ayun. So if wala ng question, so yun lang for today. Thank you for coming. And I will upload as well this recording sa offlet na lang. Okay? So see you on Tuesday. Okay. Thank you.